Let's solve this question. A helicopter is ascending vertically at the rate of 19.6 meter per second. When it is at a height of 156.8 meter above the ground, a stone is dropped. How long does the stone take to reach the ground? For all the problems related to motion under the effect of gravity, I always suggest to split the answer into two sections. In one section, you can solve the upward motion of the object. And in the other section, you can do calculations related to the downward flight of the object. It makes the problem manageable and easier to understand. So in this question, it is saying that a helicopter is going upward with a velocity 19.6 meter per second, and it reaches a certain height, and then they drop a stone, and we need to calculate the time it will take to reach the ground. So here I have written the equations of motion. When we are dealing with the upward motion of the object, we will use these equations. We use a negative sign with the gravitational acceleration, because when an object is going upward, it is going against the gravitational force, so we take gravitational acceleration as negative. Similarly, we use positive sign for the acceleration due to gravity, because the object is now moving downward into the direction of the gravity, so we take it as positive. This is just to make sure the direction of the object, whether it is going upward or downward, because we are not using a standard vector notation, so we have to use it. So when we are dealing with the motion under the effect of gravity, you can split the problem into two sections, and then you can do calculation for one. For example, if the question is I throw a ball upward, straight upward, it will reaches at some height, it will stop for a moment, and then it will fall down. So if you have a problem like this, you don't need to split the answer into two sections. Because for example, I want to know the total time it will take for the objects from point A to point C. If the question is how much time it will take for the object which goes straight up and then falls down to the ground at the same place. So for this, you don't need to split the answer into two sections, because you can only calculate the time t1, which is the time it will take for the objects from A to B, and then you can simply multiply it with 2 to get the total time of the flight, because we know this time t2 is equal to t1, so we don't need to calculate that one. Other than that, it's always better to split the answer into two sections and do the relevant calculations in those sections. In some cases, you can't use this technique. For example, if I say I am standing at a cliff and now I throw a stone upward, straight upward, and then it will fall down to the ground here. So it started its journey from point A, then it will reach a maximum height, it will stop for a moment, and then it will start falling down to the ground. Suppose that point is C. So if I ask you to calculate the time it will take for the stone or an object from point A to reach point C, you can't use this technique which I told you earlier, because now the vertical displacement is not same. AB is not equal to BC. In that case, in the first case, AB was equal to B and C. So we just calculated the time from A to B, and then rest was easy, just to multiply it with 2. Because here the heights are different. A to B is different than B to C. So we need to calculate time T1, which is the time it will take for the object from point A to reach point B. and then we need to calculate time t2, which will be the time it will take for the object to reach point C from point B, and then we will calculate these two times. So let's understand the question first, and then we will go to solve it. Here I have made a simple animation to make you understand the question very well, because there is a little twist in this question and I want you to understand it very well. So in the question it says that there is a helicopter, and the helicopter is going up with a velocity 19.6 meter per second, and the helicopter is going straight up. So when the helicopter and suppose that a person who is sitting in the helicopter is holding a stone out of the helicopter. So when the helicopter reaches a height of 156.8 meters, the person will leave the stone. So he will put his hand off the stone, and here is the twist. So we can just forget about the person and the helicopter, because when they leave the stone, we are not interested what happens to the helicopter and the person. We are interested what happens to the stone, because now stone is free to move. So here the helicopter is going up and it has reached the height of 156.8 meter, and now the person will just leave it. So my question is, what will happen to the stone at this moment when the person will leave the hand, because now the stone is free to move, right? So what will happen to the stone? Think about it and let me know. Okay, so a lot of questions, they say that the stone will start dropping to the ground. They will say it will fall down to the ground. No, it will not happen. Just remember, the helicopter was going up, straight up with that velocity of 19.6 meter per second. And when the person will just leave it, it will not start falling down to the ground, because of the inertia. It will move like with the velocity of 19.6 meter per second. So it will go straight up with an initial velocity of 19.6 meter per second. And then it will reach a height, of course, because the gravity is now working on it continuously, and it will get slow and slower and slower, and finally it will stop for a moment, and then it will start falling down. So at this moment, when it will reach a maximum height and it will start for a moment, just observe that it it will rise up to certain height, which I am calling h2, because it started its journey as a free stone from the height 156.8 meter per second. And we can assume that in fact it is the truth that it had a velocity v1 is equal to 19.6 meter per second. And we can say like it took the stone time t1 from the height 156.8 meter to the maximum height where it will stop for a moment. And now then it will start falling to the ground. So we can split the problem into two sections. One is the upward motion, and we are only concerned with the upward motion which started from the height 156.8 meter per second, because it was freed at that point. So we can consider the upward motion from the point where it started its journey as a free stone. v1 is equal to 19.6 meter per second. Then it took it a time t1 and it attained a height h2, which is in addition to 156.8 meter per second, the h2, and then it reached the maximum height. That is the upward journey. And then there is a downward journey. So downward journey for that, because for the upward journey the vf was 0, and similarly for the downward journey vi is 0, and then it will take it time t2 to hit the ground. And then similarly we can calculate its total height h as 156.8 meters plus h2, that little height it attained when it was left freely. So it started that little journey with the initial velocity of 19.6 meter per second, and it reached certain height in addition to 156.8 meters. So the total height should be h2 plus 156.8 meters for the downward journey. For the upward journey, we are only concerned with h2 because we don't care about 156.8 meter because that journey is not related to it. So let's go back to the solution and we can solve it now. So let's solve the question. Before we go to the solution, let's see what is the upward motion. So I told you the upward motion started from this point, which was 156.8 meter from the ground, because we don't care about the motion before that, because at that time it was not free. So the upward motion started from this point and it attained a height h2 and it took it a time t1. So let's calculate the time t1 and a height h2. We are actually calculating the time t1 and t2, but it's not that simple. So we need to calculate time t1. It is very straightforward and easy, but we also need to calculate h2 because we need to know the total height h. Because for the downward journey, when we wanted to calculate time t2, we need this total height h. So to calculate this total height h, we already know that the height 156.8 meter, which I call it as h1, and we also need to calculate h2 because when it was left at a height of 156.8 meter, it attained certain height, so we need to calculate that height as well, because for the downward journey we need to calculate total h, which is from the maximum height to the ground. So for the upward motion, let's calculate time t1 and height h2. Then we will move to the downward motion later on. So here I have split the problem into two sections and I have labeled them as up and down. So let's concentrate to up. Here I have equations of motions for the upward motion. So let's see what equation can I use to calculate time t1. So to calculate the time t1, I have initial velocity. I know the final velocity, which is 0. And I need to calculate time t1. I don't know the height yet, so these are the only two quantities I have right now. I know the initial velocity and final velocity. So let's go back to the equations and see which one is suitable. So I need to calculate time. So I can only use these two equations, either of these two equations. But this equation involves h and I don't have h. In fact, in the next step, I will calculate height h, but I don't have it now. So the only choice I have is this second equation. So I can use it to calculate time t because it only involves vi and vf. And in our problem, we have vi and vf only. So this equation is very suitable to calculate time t. This time t is t1 for the upward motion. So let's calculate it. So I will write this equation here. Vf equals Vi minus Gt. So let me confirm again if I have written the equation correctly. Vf equals Vi minus Gt. Yes, so I have written it correctly. I want to calculate time t, so let me calculate the time t. I will just put it on the left side, t. So it will become Vf minus Vi divided by G. So, and then because of the negative sign with the G, it will become positive and Vf will become negative. I hope you are familiar with the algebra, so I will do those steps very quickly to save the time. So this is the equation for time t. So this time t is actually t1. So I know that Vf for the upward motion, the Vf is 0 and Vi is 19.6 meter per second. So this equation will become even simpler. T1 equals Vi over G. So I know Vi, so let me put the value. T1 equals Vi is 19.6 meter per second, and G is 9.8 meter per second squared. So if I use my calculator, it tells me that T1 equals 2 seconds. Okay, so if I show you the animation, it says that it will take this stone 2 seconds after it was left at a height of 156.8 meters. It will take this stone 2 seconds to reach the maximum height. So we have calculated the time T1. Now we need to calculate H2. Okay, so before I move to the calculation of H2, now we know the question which I asked you at the beginning of the lecture, that when this stone is left at this point, what will happen to this stone? So I told you that a lot of students reply that it will start falling down. No, it will not start falling down. It will continue its journey straight up, and it will start falling down after 2 seconds. So now you know the answer to that question. So let's move to the calculation for H2. To calculate H2, let me have a look at the formulas we have. So I can, because now I know the time, I can use either this equation or this equation because both of them involves H. But I will choose this equation. So do you know the reason? I can use this equation as well because now I have the time t, which we have calculated in the previous step. But I prefer to use this equation. Do you know the reason for that? Don't worry, you will know at the end of this lecture. So I will take this equation. So I will just scroll down and I will write the equation. Negative 2gh equals Vf squared minus Vi squared. I hope you are familiar with these terms. Vi is the initial velocity, Vf is the final velocity, h is the height, and g is the gravitational acceleration. In some textbooks, these symbols may vary, so I hope you will understand what is what. So let me isolate h. This h is actually h2, so I will just change it to h2. That little height stone will rise up to in 2 seconds. So H2 is Vf squared minus Vi squared. I will divide this whole equation with negative 2g. So if it's negative 2g, I can write it as 2g, and these two terms will change their signs. I hope you are familiar with the algebra. So the next is to calculate H2. I can make it simpler by eliminating Vf squared, because Vf is 0, so its squared will also be 0. So it's Vi squared over 2g. And if I put the values, Vi is 19.6 meter per second. So I will write it 19.6 meter per second, and it's squared divided by 2 into 9.8 meter per second squared. And my calculator tells me that this whole expression equals 19.6 meters. So I can show you the picture from the animation, and it says that when the stone was left at a height of 156.8 meters. It took this stone 2 seconds to reach the maximum height from this point to this point. And it also tells us that this height is equal to 19.6 meters from the point where it was left. Okay, so now we can go to the downward motion of the stone. So the downward journey started where the first journey ended. So at the beginning, Vi equals 0. The final velocity of the first journey becomes the initial velocity of the second journey. Vi is equal to 0. It will take time t2 for the stone to hit the ground, and h is the maximum height, which is the sum of 156.8 meters, the height to which the helicopter was risen, plus the height h2 to which the stone itself risen up to a maximum because of the initial velocity given by the helicopter, because it was also moving up, and when it left the stone had an initial velocity Vi 19.6 meters per second. So let's calculate the total height h, because this is very important quantity. It will help us to calculate some other quantities later on. So total height h equals h1, which is 156.8 meters, plus h2, and let me scroll down to see what is that value, 19.6 meters. So it's 19.6 meters, and my calculator tells me that this is equal to 176.40 meters. So this is the maximum height of the object with respect to the ground. Okay, next we need to calculate time t2. But before calculating time t2, we need to calculate the final velocity of the stone before hitting the ground. But why are we calculating Vf? We only need t2, right? Because we already know the time t1, and now we need to calculate time t2, and total time is the sum of these two times. Why are we calculating Vf? Let's see the equations. Here are the equations for the downward motion. So I want to calculate time t, and these two equations actually have time t in them. Third one is useless in our case. So if I don't want to use the first equation, and I already told you that I will do my best not to use this equation, especially in this situation. Why? I will let you know at the end of this lecture, but believe me, it's not better to use this equation if you are lazy like me. So I want to use this equation because I can use it as well because it has time in it. But if I want to use this equation, just look at the other variables. All I know is the maximum height. All I know is the maximum height of the object and the initial velocity. I don't know Vf, the velocity just before hitting the ground. So I know only Vi and height. So if we have a look at the equations, if I want to use this equation, I need to know Vf. And if I want to know Vf, I have to use the third equation. Because first one is out of the question. I told you I don't want to use it, and I will tell you the reason at the end of the question. So if I want to know Vf, I need to use this equation, and in this equation, yes, because I know the height I know Vi, I can find Vf, and then I will plug in this Vf into this equation and I will find the time t. So let's do it. So first I want to calculate Vf, so I will write down this equation to find Vf. So the equation is 2gh equals Vf squared minus Vi squared. And I know the height h, and I want to find Vf, and I know that Vi for the downward motion is 0, so I can just ignore it. So I can reverse the sides of the equations for convenience. So Vf squared is equal to 2gh, and Vf equals 2gh and under root. So now it should be easy to calculate Vf. I will put the values. Square root 2 times 9.8 meter per second squared multiplied by the height. And remember, this height is the total height for the downward motion. Let me show you. This I have shown it as capital H, but in the formula it is shown as lowercase h, but it is actually the total height from the maximum height to the ground. So this total height is 176.40. So don't make a mistake to enter h1, to enter either h1 or h2. No, enter the sum of h1 and h2, which is 176.40. So 176.40 meters. And my calculator tells me that this whole expression equals 58.80 meter per second. So now we have calculated the final velocity with which it will hit the ground. So now we know the value of Vf. So if I go back to the equation, now I can use this second equation, my favorite, because I don't want to use the first equation. So I don't have any choice. I have to use the second equation. So for the second equation, I needed Vf. So I calculated Vf using this third equation. So now I can plug in the values to calculate the time t for the downward journey. So let's do it. So here I will write the equation. The second equation from that list is Vf equals Vi plus Gt. And I know that this Vi is 0, so, and I can reverse the sides of the equation for convenience. Gt equals Vf and t equals Vf, the final velocity, divided by g. And I have just calculated the final velocity here. So I will put this value into this equation, 58.80 meter per second divided by 9.8 meter per second squared. So I am using my calculator to tell me the final value of t. By the way, remember this t is actually t2. So I am changing it to t2 now. And t2 is equal to 6 seconds. Okay, so in the question they asked us what after, let me read the statement. How long does the stone take to reach the ground? It means the total time of the stone where it was left at this point, and then it would hit the ground. So we needed to calculate the total time it will take for the stone to hit the ground from this point, which was the sum of t1 and t2. So t1 is 2 seconds, and now we have t2, which is 6 seconds. So the total time t equals t1 plus t2 equals 2 plus 6, 8 seconds. So stone will hit the ground after 8 seconds. I hope you have enjoyed this numerical. And let me tell you the reason why I was not using the first equation. I did not use the first equation because if I use it, for example, to calculate the time t, I could insert the value of h. It would become a quadratic equation of this form. I have already written for you, ax squared plus bx plus c. And if you are familiar with the quadratic equation, you know it's tedious to solve a quadratic equation. So I use another way to solve this question instead of solving a boring quadratic equation. But if you like to enjoy solving a quadratic equation, go ahead and solve it that way. But I like it this way. And the second reason I don't like this equation is sometimes if I want to calculate h and I have vi and t, it becomes a bit complicated because t is here and t is there, and it involves little more calculations. So I like simple equations. Anyway, it's up to you. If you like that way, go and solve that way. It's okay.